Hi, in this video I want to go through some of the answers to question 11 all about map K in your theme 14 booklet. The first question asks simply why these rocks are faulted. How do we know? We can see on both the map and also on the cross section that beds have been displaced. The second question then asks you to label up some of these key features of the fault on the cross section. So we've got the fault plane down there where we have the displacement occurring, the footwall below the fault, the hanging wall above the fault, and then our relative movement directions of the upthrow on the X side and the downthrow on the Y side. This fault then must be a normal fault because the hanging wall has been downthrown. Question B asks about the mineral vein. This mineral vein contains the mineral hematite, which is an ore of iron. And I then ask you to work out the relative density of this, giving you the equation with the data. So if we put the numbers into this equation, we end up with 0.01 divided by 0.0019. That's going to give us a relative density of 5.26. Notice how I'm using three significant figures there, or two decimal places if you prefer, because that's the minimum number we get in the data that's given. Okay, so we don't give a whole host of additional numbers. Okay, we can only be as accurate as the numbers that we have to start with. Now, part 3 asks about hydrothermal precipitation and how this works. It's very common to find hydrothermal veins along fault planes. They provide a pathway for the hot water. So this hot water dissolves elements and then precipitates those in cracks as the water cools. And those cracks can be the result of faulting. It's really quite a common feature. Which really is the answer to question 4. Yeah, that weakness, that pathway then that's formed by the fault. Now, if we're going to use geophysical prospecting to find this, hematite, because it's dense, gives us a couple of options. Okay, we can use seismic reflection. So earthquake waves are going to be reflected or even refracted by this very dense material. And also because it's iron, it could be magnetic. So a magnetic survey might pick this up. Finally then, those of you that dug deeper, the stress that caused this fault has got to be tension. The crust has been extended, we've got normal faulting, that's got to be the result of tension. If you've got any questions about any of these answers, do get in touch. I'll see you then.